Hello and welcome to Andor's virtual demo of the Shamrock 193. My name is Tristan and I was the optical engineer on the project. I was tasked with creating the smallest spectrograph, which is automated and can take 2 cameras on the exit ports. The resultant focal length of the system was 193 millimeters, hence the name. To control the system, you can use a USB cable directly from the PC or an I2C cable from your Andor camera to reduce your cable clutter. Software control is through Andor Solus or SDK, or new for this system, Micromanager, which is a commonly used software used to control the automated aspects of microscopes and their accessories. When using it in microspectroscopy, you'll probably want to have a plunger operated wide aperture slit as the entrance. You can see, I'm going to run the system. You can move your sample around, find out exactly where you want to take your data, and then narrow your slit down and move to your wavelength range of interest to get your data. The SR193 has excellent imaging resolution when used in microspectroscopy by design, and so it really enables you to find where you want to take your data from very easily. Inside the system, first of all, you notice this hatch. This hatch on the lid enables you to change between different turrets easily. Each turret contains 2 different gratings. So if you want a low dispersion and a high dispersion grating, or perhaps a mirror, that would be 3. So you would need 2 turrets, and this hatch allows you to swap between turrets very easily. I'm going to use this stick to point so that I don't get my fingers on the optics. The basic design is a Cherney-Turner, which follows a W configuration. The light path makes that sort of shape. At the entrance, you have your slit. The light diverges from the slit and passes to a filter wheel. You may want to put in a high band pass filter, for example, to avoid the second order of lower wavelengths. The shutter is best in class. It can operate at a sustained 10 Hertz or a short burst of up to 40 Hertz. There's inbuilt intelligence in the electronics to sound a buzzer and warn you if those limits are exceeded, and to prevent the shutter from heating up too much. The light passes to the collimating mirror. Collimating mirror, to improve the imaging performance, the eye of the SR193i is toroidal. And that means it has a different radius of curvature in the X and Y directions. If you think about drawing a rectangle or a square onto the side of a donut, you'll start to sort of see how you can get 2 different radii in your X and Y. So that straightens the light up to hit the engine of any spectrograph, the dispersing element. In Cherney-Turners, you have a reflective grating as the dispersive element, and I'm going to remove it to show you a couple of features on the grating. So each turret can contain 2 gratings that are held almost back to back. There's a little room for adjustment during alignment, but they're so close to back that the center of rotation when you're selecting different wavelengths is almost on the front face of the grating, which again reduces aberrations and helps to create an excellent spatial and spectral resolution. On the side of the turret, there's an RFID tag, which is read by electronics inside the unit. And that means if you want to swap in another turret, the system will read that information off the turret and automatically update everything with the new information. So there's seamless integration of a new turret. There's no need for any user data entry. The dispersed light then goes to the focus mirror. This is patent applied for. It is motorized, moving back and forward on rails, and that has a few advantages. So first of all, it allowed me to make the system much smaller because there was no need for a bulky flange for adjustment at the camera. And also, every spectrograph that has multiple configurations of grating and port will have very slightly different focal points for each of those, which means a slightly different focus. And when those systems are QC'd, the best compromise focus position has to be held for the camera. Whereas in the 193, we can automatically adjust, the software will automatically adjust for each of those configurations and give you the best performance. So there's no need to compromise. From the focus mirror, you have the optional side exit port mirror, which will take you to an exit slit and a single point detector perhaps, or perhaps an in-gas camera to extend your wavelength range. All of these functions are controlled within a nice graphical user interface in Solus, simply clicking and dragging on various icons. The wavelength range is perhaps the most important. You just drag your slider along. You can enter in a specific wavelength if you want. The slit you can drag open or closed, or enter in a value from 10 microns up to 2000. And then, of course, on a wide aperture slit, you can use the plunger to open fully wide up to 15 millimeters. The shutter has various modes in auto operation, or can be held open or closed. You can click on it to cycle through those. The filter wheel, you can choose a different filter up to 6. Grating, just click on the grating you want. Focus mirror, drag it or enter in a different value. Or if you have a spectral peak in the middle of your acquisition, you can click autofocus and the system will automatically find the best focus for you. So I'd like to talk a little bit now about other Andor products. Also in the Shamrock range of spectrographs of Turner design, we have the third meter, and there's also the SR500 and SR750, again where the number designates the focal length of the system. The other spectrograph we have is an E-shell type spectrograph called the Andor Mi-shell. E-shell is French for ladder, and that's because an E-shell spectrograph projects the spectrum as if it's like rungs on a ladder. And each rung contains a slightly different wavelength range. And then the software can stitch together all those different rungs to create a large wavelength range with high resolution, all in a single acquisition. On the other side of you, you can see a range of Andor cameras, from CCD for spectroscopy. We've got imaging cameras, we've got CMOS, and intensified CMOS as well. So in conclusion, the SR193 has an excellent cost to performance ratio. It's very compact, it's easy to use, and if you have any questions about it, then please contact your nearest Andor representative and they'll be happy to help, or just browse through our website. Thank you.